Hello everyone. Please note that this is a NotebookLM video presentation. Thank you NotebookLM. Hope you find it useful.
You know, we live in this incredible time where AI seems to be doing impossible things, but there's this weird paradox, a really strange gap between its massive power and, well, its surprising fragility. And it really all boils down to this question, right? How can a system that can create unbelievable art from a simple text prompt or solve complex games be so easily tripped up by something a toddler wouldn't even blink at? This is the exact puzzle we're going to try and solve today, and it all comes down to one of the most basic building blocks of intelligence: perception. I mean, the contrast is just night and day. On one side, you've got this insane ability to crunch trillions of data points. On the other, these systems can be completely fooled if you just change something small that wasn't in their training data. They even struggle with stuff like object permanence, the basic idea that an object still exists even if you can't see all of it. To put it bluntly, perception in today's AI is just brittle. It doesn't have that robustness that we humans completely take for granted. And this isn't some small bug. It's a huge bottleneck that's holding AI back from what it could really do. So, where do we even start to look for a solution? Well, we look to the original, the gold standard of intelligence, the human brain. By digging into its perception playbook, researchers are hoping to find a kind of blueprint for building AI that's smarter, tougher, and a whole lot more efficient. So first, let's just get on the same page about what perception even is. It's not just about seeing or hearing, right? It's the entire process of taking in all those raw signals from the world and turning them into something that actually means something. The source material for this explainer calls it the gateway to intelligence, and that's perfect, because everything else, learning, remembering, reasoning, it's all built right on top of that foundation. And the brain has this really elegant, multi-stage way of handling it. First, you've got sensory stimulation, just taking in the raw data. Then comes organization, where the brain starts sorting and structuring all that info. And finally, there's interpretation, which is where it mixes that new data with everything you already know to figure out what's going on. This process, it holds some major clues for AI. And that leads us right to the key lessons from our own brains. We're going to zoom in on two really powerful ideas from cognitive science that show exactly what current AI models are getting wrong. First up is something called perceptual constancy. This is your brain's incredible, almost magical ability to know that your coffee mug is still your coffee mug, whether it's in a super dark room, under a bright spotlight, or if you're looking at it from the top down or from the side. The object itself is constant, even when the information hitting your eyes is changing like crazy. And this is where you really see the difference in how we do things versus how AI does them. Your brain just gets the idea, the concept of a chair. But current AI, it often has to use this brute force method. It has to be shown thousands, maybe millions of pictures of a chair from every possible angle, in every type of lighting, just to learn what you figured out as a kid. And if it sees a new version it wasn't trained on, it can just fall apart. The source material really nails it here, saying that AI is largely reliant on the training distribution. What that means in plain English is that it's not really learning a deep concept. It's just memorizing patterns from the data it was fed. And that's exactly why it chokes when it only gets a partial signal or sees something slightly new. Okay, the second big lesson is something called selective filtering. I want you to picture this. You're in a super crowded, noisy coffee shop. Your brain has this amazing ability to just tune out all the background chatter, the clanking of dishes, and zoom in on the voice of the person you're talking to. It's dynamically filtering what's important based on what you're trying to do. AI models, for the most part, they just don't work that way. They tend to treat every single piece of data that comes in as equally important. Getting rid of noise is usually a separate step, not something that's guided by what the AI expects to see. They have to be specifically trained to ignore junk data, whereas for us, that's just a fundamental part of how we perceive the world. So when you put these two ideas together, perceptual constancy and selective filtering, you start to see these huge blind spots in AI research. But those blind spots are also massive opportunities. And the paper we're pulling from lays them out super clearly. AI needs architectures that are more dynamic, more modular, kind of like the different regions of the brain. It has to get past these brute force hacks for basic things like object permanence. And it desperately, desperately needs to get better at using context and goals to guide what it pays attention to, just like we do without even thinking about it. But let's take a step back for a second. Fixing perception isn't just about making better image recognizers. It's actually a crucial stepping stone on the path to the holy grail of AI research, creating artificial general intelligence, or AGI. Because think about it, truly general intelligence needs way more than just processing data. It needs to be able to generalize, to interact with the physical world, to even understand social cues. A rock-solid, brain-inspired perception system is the foundation for all of that. I mean, you can't have a robot with embodied cognition if it can't even reliably tell what a doorknob is. And that leaves us with this one big thought. For years, the path to smarter AI was all about more data, more computing power. Bigger is better. But maybe, just maybe, the real breakthrough isn't going to come from building bigger and bigger machines, but from looking inward and asking if the secret to building the mind of the future has been right here inside our own this whole time.